Hi, good afternoon. Thank you for joining us in this webinar during your lunch hour. My name is Christina Lucci, and I'm a developer here at DevMethod. Today, we're going to be talking about blockchains. So, quick disclaimer, I am in no way an expert on blockchain. I've taken the IBM Blockchain Foundation course on Coursera, and I've gone to a couple of meetups in the city and read some extra reading, but definitely not an expert on the subject. I just wanted to share some knowledge. And also a quick disclaimer, there will be a Q&A portion at the end of this talk. So just leave your questions in the comment section below. And after I'm finished going through the code, I can get to as many of them as possible. So let's begin. What is a blockchain? So let me start by saying that there is a common misconception for people that don't know blockchain, that it's the be-all and end-all of blockchain is Bitcoin. Completely not true. A blockchain is simply a digital ledger of records formed of blocks of data. These blocks are linked together through cryptographic validation, which is just a fancy way of saying, can these blocks and this link be verified as not having been tampered with their unique signatures? An unbroken link means that no one has messed with the block, and which means that its unique signature hasn't changed. And that is what we know of as a blockchain. It's great that blockchains offer verified data, but what has made them so popular with cryptocurrency companies like Bitcoin? Answer is decentralization, which means that the records aren't stored in a single location. It means that they can be shared with everyone among that network, and they can't be changed by a single person. They're immutable. So now that we have a brief understanding of blockchains, what can they be used for? So I mentioned a bit that blockchains are most commonly used with cryptocurrency companies like Bitcoin. You send money to individuals, you send money to merchants, but they can also be used for digital assets like stocks and bonds. Not only can Bitcoins be used in the financial industry, but they can also be used to verify records, something that big data companies and industries are interested in, even the government, even the medical field. So enough of the conceptualization of what a blockchain is. Let's get into some of the code. Today, I'm going to be coding in Java, but feel free to use whichever language you're comfortable with to build out your blockchains. The code has been recorded so that I don't make any mistakes on air, but feel free to follow along. So we're going to start off with a key component in a blockchain, which is a block. And we're going to initialize the hash variable, which is going to hold the block's digital signature. We're also going to initialize previous hash, which will contain the previous block's digital signature. We're also going to be initializing the data variable, which will be holding the unique data for that block. And lastly, we're going to create a timestamp variable so that we can keep track of when the block is created. So let's create a constructor for this block. We're going to be passing in the data, and we're going to be passing in the previous hash. Now, we don't have to pass in the current hash because this is generated when we create this block. So we're going to set this data to data and this previous hash to previous hash. And we're going to set the timestamp to new date .getTime. And you can see that on line 3, I've already imported the date library. Now, we've completed our block, our initial block. And what we want to do now is generate the digital signature of each block. So here I've created a utility class, and I'll be creating a helper method right now in the class, as we'll be using it later on throughout the blockchain code. So I'm creating a new method here called apply SHA-256. And what this method is going to do is it's going to take in the data that we pass it. It's going to apply the SHA-256 cryptographic algorithm to it, which will create an almost unique digital signature. And this will pass back that digital signature as a string back to whatever is calling this. You can also see later on that I'll be using something called JSON Builder so that it can print out some of the pretty items for what we're going to see in this method. So you can see that on line 18 that we are setting this integer that we're getting back to the hex string. And finally, returning the hex string that we've just created using the SHA-256 cryptographic algorithm. And since this is a try, we're going to also be adding in an exception catch for if anything fails, which hopefully it won't. So now that we've created this helper method, we want to access it. We want to add it to the block class and create that digital signature for that specific block. So what I've done is I've created a calculate hash method, and this is where the calculate hash is going to receive the signature that's returned from the apply SHA-256 method. So here you can see that we're passing in the data that we've created for the block. So the previous hash, which will be the information, which will be the hash from the previous block in the chain, as well as the timestamp and whatever new data that we've created for that block. And we'll be returning that calculated hash. So now that we've created this method, we're also going to want to add it to the constructor. You may be wondering why we're adding in all of this information. We want to, and why specifically we're adding it to the constructor after everything has been, after all the data has been created. So the reason why is because at this point on line 17, we have all this new information that we want to be added to the block and to be encrypted, so that even if something small like the timestamp changes, or even if something like the data changes, that we know if someone has tampered with it. And we know that if it has been tampered with, then that means that the digital signature of this block will have been changed. So far, we have created the block and we've created the string utility to apply that the encryption method for that digital signature. But no blockchain is complete without the actual chain. So here, creating the public chain class, and in the main method, we'll be passing in an array of arguments. And here is where we'll be generating the new blocks. So to keep in line with what Satoshi Nakamoto had first done, he named his first block the Genesis block. So keeping in line with that name, the first block is the Genesis block. And you can see that for the first argument, adding in the data, which is I'm number 1, and the second argument is 0. The reason why is because this Genesis block has no previous block to it. So that will be its previous block hash. As we begin to code out the second block, you'll see that we'll be adding in the Genesis block's hash as the second argument there. And the reason why is because if you think about the chain and how it's structured, the Genesis block is the first block. The second block is the second. So if you look to the previous block of that second block, it's the Genesis block. And we need that hash to ensure that the chain that we'll have created isn't broken. And we're going to continue doing the same thing for the third block, where we'll be adding in the data string, I'm number 3, and we'll also be adding in the second block's hash, as that is now its previous block's hash. And we're going to take a short break and go into the code that we see here, which will show you what you can see from that hash. So you can see that each of these hashes that we've created for these blocks is completely different. And so they will continue to be completely different as we continue to run this method. The reason why they're different, even though the data hasn't changed, is because the timestamp has changed. So as all of the input that you're putting into this apply SHA-256 method, as even if the most minute piece of data changes, the digital signature of that block will change. Well, let me go back to the video. So now we have a good start to our block, to our blockchain, but it's not it's still not a chain. We've just printed out all of the different blocks that we've created, but we need the actual chain. So what I've done here is I've created an array list of blocks entitled blockchain. And in this main method, we are going to refactor this a little bit so that we can add these 3 blocks that we've created into that blockchain array list. So it's going to be very similar where we add in the initialization of that first block. And again, very similar to the initialization of the second and the third block. But something is going to change for the second and the third block when we add it to this array list, which you'll see in a second. So you can notice that on line 14, I've just deleted Genesis block. And the reason why is because that is no longer a valid variable name. So we want to create this blockchain based upon what we're seeing in the array list. So right now we're seeing the blockchain and we're getting the size of the blockchain array list and subtracting 1 so that we get the proper hash that we need and passing that in. And lastly, we'll get to the blockchain JSON builder. We're going to be using JSON builder pretty print to make it a little bit nicer when we show it up in the console later, after the rest of the code has been complete. And printing that out into the console. So great, we have a chain of blocks, but it's still not a blockchain quite yet, even though we've added it to an array list. What we need to do is we need to check the integrity of the chain of blocks. And we can do that by creating a Boolean method called isChainValid. And so here, we'll be looping through each of the blocks that we've added to the blockchain array list. And we'll be going through and saying, are the hashes that we see within this array list the same? And so we will be calculating them again to ensure that the hashes are as they should be. So here we'll be going to the current block and getting the first index in this case, in getting the index of that current blockchain array list and getting the previous block, and then we'll be checking to see, 1, if the current block's hash is equal to what it should be calculated as. And so we want to ensure that the integrity of the blockchain is kept throughout its coding life. And so we know that if the current block's hash is different than what it had been calculated as, then we know that that block has been tampered with, which means that that blockchain is no longer secure. So this is going to return false. And we're also going to do something similar with the previous block, where we're going to ask if the hash is equal to the previous block's calculated hash. And to the current block's previous hash. And will be, and very much the same, if it's not equal, then that means that, again, that block has been tampered with, which means that the block is no longer valid. And you know that somewhere within that block, someone has attacked that block and changed the data. And lastly, if all of these things do turn out to be true, where the current block's hash and the previous block's hash are equal, and that everything is good in the world for this block, then you know that the chain is valid and it will return true. So next, we're going to validate the actual block. And I'm going to pause the video here for a moment and talk to you about mining, because that's exactly what validating an individual block is. So we've verified that the chain is valid, but we need to validate the new blocks that are joining the chain. And this is where mining comes in. So we're going to talk about a real life scenario here, where Bitcoin's network nodes select the longest honest blockchain. And so what that means is that when blocks are honest and when they're added to the blockchain list, that chain continues to grow and grow. But as soon as the system sees that a block is no longer valid, it's not added to the blockchain list, which means that blockchain is just cut off short. And so that's why Bitcoin uses the longest blockchain to ensure that it's honest as they're using that data. So miners validate the blocks before they go into the chain. And this is where the money comes in, that a lot of people are interested in, specifically for financial industries, because miners get a miner fee. That's a pun, which is a small percentage of the money that they get from the blocks to ensure that the block is valid. And so mining is really important. They help to keep the network fair, they keep it stable and secure. I had mentioned earlier that not everyone has access to every single aspect of the blockchain. And so with miners, they don't have access to every single block in that blockchain. And that's why that keeps it fair. So not everyone is, if you have a super overpowered computer, you're not taking up all of these blocks and validating them. You're spreading the wealth. And so a lot of people that are interested in blockchain are also interested in becoming a miner. So you definitely can become a miner, but you're going to need a fair amount of money to purchase all of the computer equipment required to handle some of the more secure block problems, which we'll cover later. And you'll see in just a moment why you're going to need so much money for the equipment. So we're going to create a basic mining method here for our blockchain. And we're going to require the miners to do a proof of work by trying different variable values in the block until the hash starts with a certain number of zeros. And that's where the integer nonce comes in, where we'll be testing it as 0. In this method, we're going to be adding in the difficulty. And so the difficulty is going to define how many zeros you want to test within the block's hash that you're looking at. And so you're searching through the string to ensure that the correct number of zeros, or whatever you've set your nonce value to be, is correct within the hash. And this verifies the block that is validated. And here you can see that we're mining that out and printing that into the console. And this is the extent of what it takes to build a blockchain. Now, we're going to go out into the chain method and set that difficulty integer, which we're going to set to, I believe it was 4, which is a pretty stable difficulty level for most computers nowadays. But if we go into Eclipse and we test out this second chain, you'll see that these blocks that have been mined have a really low amount of seconds to mine. And if we go into here, which is the chain method, you'll see that the difficulty level is 4. If we set this to something like 6 perhaps, and we ran this, you can see that already it's taking considerably longer. And so this is what I was talking about with related to mining, where if you're planning on mining and the difficulty level on those blocks within that blockchain is extremely high, you're going to need a lot of firepower in your machine to ensure that you can mine those blocks. So for instance, Litecoin, one of the another popular cryptocurrency companies, the difficulty level that they have for their chain is around 450,000. So right now you can see my computer, my little MacBook Pro, is already having a tough time with a difficulty level of 6. So can you imagine how difficult it would be with a difficulty level of 450,000? See, it took 69 seconds to mine one block, which is ridiculous. So that concludes the coding section, and we're going to move into the Q&A section. So give me a moment to stop sharing my screen and get your comments in front of me. So far, no questions. Sure. So, hi, Jordan. So the difficulty level in blockchains, and keep in mind, I am, again, not an expert in the subject, but the difficulty level is where you're testing the hash to ensure that it is valid, that the integers that you're passing in as a nonce are present within that hash. And I would definitely encourage you to Google this and learn more about the difficulty level within blockchains. Before anyone answers another question, I wanted to let you know that we will be posting this up to GitHub on our company page so that you can look through this code and see exactly how blockchains work and play around. Maybe if you have an amazing computer setup that you can add the difficulty level up to 10 or 15 and see how that goes. Hi, Vishal. How does a developer get more firepower to perform higher difficulty level mining? Good question. So you're going to need a lot of money. When you're dealing with the performances of your machine, this has been an issue for a lot of hardware companies where the video cards need to constantly be updated, and the video cards go from being maybe a few $100s to being thousands of dollars. And all of that new hardware that you see that's incredibly expensive for computers is all due to blockchain and to the miners that need all of that extra firepower in validating those blocks and getting those miner fees. You're welcome. Anybody else have questions? Hi, Maria. Is it possible to bankrupt a blockchain in order to lessen the firepower necessary by starting over? I'm not entirely sure what you mean by that question, but I assume you mean the fees that the miner gets from validating the blocks in the chain. And so you definitely, you can't bankrupt the blockchain. There's already the money that's being passed, specifically with Bitcoin, the Bitcoin that's being passed over that blockchain is a lot of money, and the fee that's part of the price for what you're buying is already added into those blockchain into those Bitcoin purchases. So you can't really bankrupt a blockchain. Let's see, Jordan, do you have thoughts about the benefits of specific popular blockchains like Bitcoin versus Litecoin versus Ethereum? I'm not entirely sure about that. Well, about how I would answer that. I did look into Bitcoin and I looked into Ethereum, but I don't feel comfortable answering that question. Okay, Hui, how can blockchains be used in industries other than crypto? Oh, so earlier in this talk, I had mentioned that blockchains could be used in within the financial industry, within stocks and bonds, as well as within big data type of environment. So the government and the medical industry, with regards to record keeping and the data that's passed along there. Let's see, Vishal, can you elaborate on how a developer may unit test their blockchain code? So unit testing a blockchain code is very similar to the rest of the way that you test other code. So you'll have the methods that you have for for validating the chain. And so you'll create a stub array of the blocks that you're looking to test, and you'll be creating perhaps since it's a stub array, you would have stub data, and it shouldn't take too much firepower for your machine to apply the SSH 256 cryptographic encryption. But once that's been encrypted, you can just test that data to ensure that, let's say, in one of your tests, if you had a happy test where everything worked exactly as it should and that no blocks were tampered with, then that would work as it should be. But then you could have a bad test, which is where if the block, if you could pause the code so that the block would be changed after you had created it, then that would change its digital signature. So that way you could ensure that everything is working properly when you're validating that chain. Let's see, Jordan Cooperman. What are the major strengths or weaknesses with regards to blockchains? So a major strength is the fact that it's decentralized. So the fact that this was the reason why it was so popular for Bitcoin, and I believe within the liberal political group, where the bank isn't controlling all of that data. It's shared with everyone. Okay, the specific types of blockchains. So again, I'm not all that familiar with Bitcoin versus Ethereum and Litecoin, but you should definitely look into them, because I do know that Bitcoin and Ethereum are competitors in a sense, and so they must have some strengths and weaknesses where you would choose one over the other. So we can post some comments into this video for any of the questions that I can answer after I've done some research. But sorry I couldn't answer that. And again, Jordan, could you use blockchain to send validated images securely? If so, would those files be unique, or would somebody be able to easily send the image to another user once downloaded? Validated images. So you could, it isn't so much about sending the validated images, but the fact that the image would be secure within that block, so that it's not being sent, but it's being recorded. And if that image is changed, then you know that the blockchain is no longer valid. It's a dishonest blockchain. So that way you wouldn't want to send anything from that blockchain. Let's see. And would the files be unique, or would somebody be able to easily send the image to another user once downloaded? So again, each block in a blockchain is very unique. Even if you have the same exact data in two blockchains, the timestamp will be different, which will mean that the digital signature of those blocks will be different within the chain. So that block will be unique. And again, there are theories about SSH 256 theoretical, and that's why I said it's almost unique. So I encourage people to look into SSH 256 to see why it's almost unique. It's a pretty cool concept. Let's see, Julia, How long do you think it would take a mid-level full-stack engineer to become a blockchain engineer? So I'm going to assume that a full-stack engineer has no idea about what blockchain is, and that they're pretty familiar with some common languages like Ruby on Rails, Node, React, perhaps Java. But I think that if they wanted to graduate into becoming a blockchain engineer, that they would definitely need to focus on the back end, as this is a very back end type of topic. There really isn't a front end for blockchains. I assume that you could put them on the front end, but it's all that logic is really in the back end. And so you would definitely need to focus on back-end logic to ensure that you really understand how to test that back-end logic to ensure that blockchains are acting as they should. You'll also want to look into the different languages that they use in blockchain. So I did mention earlier on that you could use most any language in blockchain, but there are around 3 to 4 very prominent languages that you would use for blockchain engineering. One of them is C++, which is part of the IBM Foundation course on Coursera, which I've been taking, and it's a pretty cool language. I like it. You can also use Java, which I used today in our webinar. You can use JavaScript, which is a pretty cool language. I haven't really delved into building out a blockchain using JavaScript. And you can also build a blockchain using Python, which is a pretty cool language to go into. So I think that if you want to become a full stack engineer, become an engineer for blockchain, you would definitely need to look into those languages. Let's see, Ed Road. Okay. Gene. So let's see, you don't get the value of mining. So the value of mining, it's a little bit confusing in the concept of this webinar because this is all within the same code base. But imagine that you were that intermediary between the people that were buying things using let's say Bitcoin, and the company Bitcoin that is handling all of that data. Bitcoin by itself can't sift through all of the blocks being added into the blockchain by itself. So it's taking on the miners that are across the globe that are taking in all of those new blocks coming into the blockchain and verifying that that block is valid before it goes into the chain. And that may at face value seem like it's better for Bitcoin, but you also have to remember that miners do get a fee for this. And that's why it's become such a popular thing overseas, where they'll validate all of these blocks going into a blockchain, and they'll get millions, billions of dollars due to those really tiny fees. So that's why mining is important. It keeps the chain safe. It keeps the chain secure with the data that's going in. And I had mentioned earlier that it keeps things fair because there isn't just one miner going through all of the blocks. There are a lot of miners going through the blocks because that blockchain is separated among a lot of different nodes on the network that are going through those blocks. I hope I answered your question well. So why would you become a blockchain engineer? Well, one, I think it would be a really great challenge to go through that and to create really secure things. But as a more finite answer, blockchain is, even though blockchain was created about 10 years ago, it's still a new and upcoming technology. It's the new frontier for developers and for data keeping. And so even though it's not always related to money for Bitcoin and Litecoin, it's also growing into being related to data keeping to ensure that the data that is being passed through, let's say in the medical industry, all of those records and the data being passed, you don't want anybody to hack that. And it is beyond impossible to hack a blockchain because there are so many things that you have to take into account that if you change just one block in the chain, then it breaks. So you would have to have a quantum supercomputer, which hasn't really been invented yet. I know people are playing around with the idea, but it honestly hasn't been invented yet to be able to hack a blockchain. And so the data that's being put into a blockchain is right now one of the most secure pieces of data that you can have. And so I think exploring that and bringing that into other sections of the world is a pretty cool thing to do. Because I mean, the other day I watched a video where it was an audio video where somebody had taken Barack Obama's voice and had made him say some pretty weird things. And so that could have probably been solved with a blockchain somehow. And the idea of adding that into the rest of our lives, since there's so many new different things about fake within our society, that I think it's pretty important to look into. Okay, so what do you think is something one should keep in mind when trying to become a blockchain engineer in terms of skills and enhancing your competitiveness? Becoming a blockchain engineer, there aren't very many. That's why blockchain engineers are paid so highly. They get paid in the high hundreds of thousands to $1 million per year. So when you're thinking about becoming a blockchain engineer, you do need to enhance your skills. You want to be the top of the class so that people will want to hire you. So I think something that you do need to consider for that is you want to, specifically if you're looking to become the engineer, not the miner, is you want to look into different cryptographic encryptions. So SHA-256 is only one of the ways that you can encrypt, create a digital signature. There are many other ways that you could do that. And so becoming familiar with the security of data is one thing that's extremely important. And from there, following the best practices of code, which is something very basic to say, but you want code that's readable. And so when you're dealing with a really intense topic like blockchain, you really want your code to be readable. So I think that really understanding the language that you're working with and being able to write it clearly and concisely is very important. Thanks, Vishal. Thanks, Ed. You guys are great. Thank you so much. Any more questions? Okay. So I don't think we have any more questions. So I'm going to sign off now. And it was great talking to you guys. So follow us on all our different social medias. Continue to look into this blockchain webinar. Look at our GitHub. Look at our GitHub profile so you can see the repo for this blockchain code. And don't forget to subscribe as the iconic YouTuber. Thank you so much, guys. Have a good night.